Welcome back. For this question, our goal is to find the closed integral of the vector force field, where c is a smooth path from a 1 0 pi to b 2 pi 1. And we're given some vector force function. In order to complete this question, we need to find the dot product of the direction vector with the force field. So the dot product with the direction dx, dy, dz will be multiplied by the dot product to the force function, where the dx will be multiplied with the first term, the dy will be multiplied with the second term, and the dz will be multiplied with the third term. In the end, we should get something with some activity dx plus some activity dy plus some activity dz, where it can be stated that the first term for dx is represented by m, n, and p. And then from here, we can be able to take the integral of the sub functions. M dx. So that's the first term, z cos y minus 6x. So I'm going to represent this as the integral of z cos y minus 6x dx. And then from here is just taking the integral in terms of x. Now, z cos y doesn't have any x, so we'll have to integrate it. So the updated version should have an x. Then just rewrite. So z cos y. And as for the second term, there's already an x, so we'll have to take that by one more degree. Minus 6x to the second over 2. But the 6 divided by 2 is just 3, so I'm just going to keep it as 3. 3x squared. On top of that, I need to restate, because this is indefinite, some constant. But the constant is in terms of yz, since we have already worked with x. Now, for the next integral, going back to the notes, we're now working with the n dy. So that's the second term. So n dy. So we'll be working with this. Choose z minus xz sine y dy. Now our goal is to integrate in perspective to the y variable. For the first choose z doesn't have any y, so we'll have to integrate so that there is a y. 2yz xz sine y. Now, we need to take the integral of sine, which is negative cos. So that changes this sign. Xz cos of y. And plus some constant. But the constant is in terms of xz, since we are already working with y. As for the third and last, we have identified the integral of dx, we have identified the integral of dy. Our last is by dz via the third term. So p dz, which is the 2y plus x integral of 2y plus x cosine of y dz. We're integrating in respect to z. 2y doesn't have any z, so we'll have to incorporate the z. 2yz. X cos y does not have a z, so we'll have to incorporate a z to that. So xz cos of y. And the fact that we're working with the z variable the constant will be in respect to xy. Now, as for the next part of the question, we need to find a potential function of the vector force field so that we can be able to take the integral from the bounds. So what I'd like to do is to find out what each of these three subintegrals have in common. They share xz cos y, xz cos y, and xz cos y. So I'm going to put that. So the potential function we can start with the xz cos y. Now the next thing that the three subintegrals have in common is the 2yz, and the fact that this one doesn't have a 2yz, but we can assume that that constant is also the 2yz. So that's plus 2yz. And here's a negative 3x squared. We can assume that because of the constants, those have the capability to be the negative 3x squared. So I'm just going to restate that as negative 3x squared. And since, again, we're still working with a constant and not a closed integral, we need to put plus some k value. So that's a potential function. The last part of the question is now to take the integral from the bounds from a to b. Keep in mind that the closed integral of the function of the force times by the derivative, the direction, is the same thing as finding the force, the work force of b minus the work force of a. And we have already identified the potential function, so we can just copy and paste this xz cos y plus 2yz minus 3x squared. And we're going to take this integral, assuming that we're going to subtract the higher bound, the b value, so that's b of 2 pi 1 minus a, which is 1, 0 pi. And then just plug and chug, so by substitution. Substitute 2 in for x, pi for y, and then 1 for z, and the same thing for a. So I'll do this in yellow. X, that's 2. Z is 1 cos of pi plus 2. The y value is pi. And z is 1 minus 3. Your x squared is 2. So 2 times 2 will give us 4. Minus. So this is the b term. And now for the a term. 1 times pi, it's pi, and cos of y, which is cos of 0, plus 2 times yz, so that's 0 times by pi, minus 3 times by 1 squared. And then now just the meticulous work. Cosine of pi is negative 1. Negative 1 times 1 is negative 1, times 2 is negative 2. 2 pi 1 is 2 pi. 3 times 4 is negative 12. Granted that we can simplify this a little bit further out, so that's 2 pi, negative 2 minus 12 is negative 14. Now for the red, cos of 0 is 1. 1 times pi is pi. 2 times 0 times pi is 0, so I'm just going to cross it out. And 3 times 1 to the second, so that's minus 3. Be careful with the next step. We're going to distribute the negative sign. It's minus pi plus 3. And then now just combine like terms. 2 pi minus pi is pi. And negative 14 plus 3 is negative 11. Since the fact we're working with the workforce, we need to specify the correct units for the answer. So find the work done on a smooth path from A to B will be pi minus 11 work units.